A very good morning to one and all. Welcome to the session of engineering drawing. In this class we are going to discuss projection of line or orthographic projection of lines. In the last class we have discussed a few concepts related to this projection of points and projection of lines, and we came to conclusion that always we have to follow either first angle projection or third angle projection. That means some countries follows first angle projection, whereas some countries follows third angle projection. Now, as India is a country which follows first angle projection, we concentrate more on first angle projection. That means we should not forget. It doesn't mean that we should not forget the third angle projection. Both should be kept in our minds, but most probably we will follow this first angle projection. Now, so as to analyze this projection of lines, always it is better to take some book and pen. Assuming here we have to assume, if you open this book, let us assume this plane as vertical plane and this plane as horizontal plane. The line which divides the horizontal and vertical plane is called as reference line or XY line. Now, as we consider the line in first angle projection, already we know that how can you notice that an object is in first quadrant? By the terms above HP and in front of VP, you can notice that the object is in first quadrant. If you project object in first quadrant, it is called as first angle projection. Here also we have to coming over to the line, as we know that as you assume this pen as a line, as we know that line is nothing but made by means of infinite number of points. Generally, the line will be represented with two endpoints. If you assume this point as A and this point as B. In projection of points, you come across only projection of one point itself. The point looks like point itself from any of the view. But whereas here coming over to the lines, now if this position is like this, from front view you can look the true shape of the line, and whereas from the top view you can see only the topmost point of the line. If the pen is like this, that means we are assuming the pen as a line. From top view you can notice the true length of the line, whereas from front view you can notice only this point. If it is like this, the true length of the line can be seen from either of the view, either from top view or from front view. That means here one thing is clear, that either the line looks in various forms according to its position. Now let us see what is the first position of the line. Line parallel to VP and perpendicular to HP. Line parallel to VP and perpendicular to HP. That means this is the position, and always I said that this plane is called as vertical plane and this plane is called as horizontal plane. You are the viewer here. You are the viewer, and always in first angle projection, object will be there in between observer, that means you and the vertical plane. You are the observer. That means this is the position. Line is parallel to VP and perpendicular to HP. Perpendicular in the sense what? This line has to make angle 90 degrees with this horizontal plane. This line has to make angle 90 degrees with this horizontal plane. Now, as you look like this, the true shape of the line can be seen from which view? From the front view. As we know that always front view can be seen on the vertical plane, and we will represent the points in the front view with dash. That means this one, suppose if we assume this line as AB, A dash and B dash, and from top view you can see only one point. This is the point. Suppose if it is A, you can see point A, but B cannot be seen. Therefore it has to be represented with A of B on horizontal plane. Always top view can be seen on horizontal plane, whereas front view can be seen on vertical plane. Now the first condition we have taken is line parallel to VP and perpendicular to HP. That means first of all you have to imagine the position of the line according to the question. Once if your imagination is correct, you can answer any question related to this projection of lines. This is the position. This line is parallel to VP and perpendicular to HP. And one of the endpoints on the line is lying certain above HP, and the entire line is some xmm in front of VP. Some xmm in front of VP. That means it is at a distance of some xmm in front of VP, and the line is some ymm above HP. Position of the line is parallel to VP and perpendicular to HP. Now always we have to start from the view from where you can see the true shape or true length of the line. Here from which view you can notice the true length of the line? From front view you can notice the true length of the line. That means here, that means for example, if you project, you are the observer who are standing in front of this plane. If you put some torchlight or any other light on this line, what happens? The shadow of this line falls on the vertical plane. The shadow of the line falls on the vertical plane. As the line is some ymm above HP, as this line is some ymm above HP, the shadow of the line also falls certain distance y, at a distance of y above this reference line or xy line. This is the xy line which divides horizontal plane and vertical plane. Like this. If you put some light on this, the true length can be seen on vertical plane, straight line, certain height, at a certain height, some ymm above the reference line. Whereas from top view, you can see only the point. As you assume this line as AB, from front view, you have to represent this line as A dash, B dash, which is at a distance of some xmm above the reference line, ymm above the reference line. From top view, you can notice only one point. That means A point can be seen, whereas point B, which is below this one, cannot be seen. Therefore, you have to represent it as A of B. A in brackets you have to represent B, which is called in general form as A of B. If you put torchlight on this, just you can see a point on the horizontal plane. That means if you tilt the horizontal plane in clockwise direction, the line comes above the reference line, whereas point comes below the reference line at a distance some xmm in front of, at a distance some xmm in front of this VP. That means the point can be seen at a given distance in front of VP. Now let us see a question with reference to the question. Let us see the first condition, the line parallel to VP and perpendicular to HP. A line AB of length 50 mm is parallel to VP and perpendicular to HP. One of the end points of the line is 20 mm above HP and the line is 30 mm in front of VP. Draw the projection. This is of the condition that what line parallel to VP and perpendicular to HP. Please underline the term parallel to VP and perpendicular to HP, and in the question the two endpoints of the line is named as A and B. That means one of the endpoints is A and the other endpoint is B. The shortest distance from this A to B is given as 50 mm. That means the line's length is given as 50 mm. Its position is given as parallel to VP, that means vertical plane, and perpendicular to HP. As we know that, as we discussed it just now, if the line is parallel to VP and perpendicular to HP, the true shape of the line can be seen from front view. That means, so as to analyze this, first let us imagine with the book, and later on if you don't have any clarity, just take some rough figure. This is rough figure. Here let us assume this line as VP and this line as HP. That means the line, vertical line represents vertical plane and horizontal line represents horizontal plane, and the line which divides this HP and VP is called as reference line or XY line. Now according to the question, line's length is given as 50 mm and it is named as AB, and it is named as AB. This line is 30 mm in front of VP and 20 mm above HP. It is what given in the question. Now always we know that observer will be looking from your right hand side as you draw the figure like this. That means the object, if it is, as this is in first quadrant, as we know that in first angle projection always object will be in between the observer and the vertical plane. Here what is the object here? The object is the line AB. Therefore from front view you can see the true shape of the line AB. Always we have to start from the view from where you can see the true shape. That means from front view you can see the true shape. That means if you project a light, the shadow of this line AB falls on the vertical plane. That means always where it falls at a height of 20 mm above the reference plane. As this is front view, we have to represent it as A dash and B dash. And once again, if you look from the top view, you can notice only point A. B cannot be seen. If you put torchlight or any other light on the line from the top, the shadow of this line in the terms of point can be seen on the horizontal plane. At a distance 30 mm in front of VP or from reference line. This distance will be of 30 mm. And this vertical distance will be of 20 mm. As you notice, only a point A can be noticed. That's why I have represented this point as A, whereas B cannot be seen. That's why I have represented as A of B. Now if we have to tilt this horizontal plane in clockwise direction up to 90 degrees. 90 degrees in the sense what? This is what? 90 degrees. Up to 90 degrees. If you tilt the horizontal plane 90 degrees, what happens? VP comes above the reference line. This is what the output is. This is the XY line, and vertical plane comes above the reference line and horizontal plane comes below the reference line. And now here you have to start the projection from the view where you can see the true shape. Here true shape can be seen from which view? Front view, which is represented as A dash B dash at a height of 20 mm. At a height of 20 mm. And as this horizontal plane, on the horizontal plane we have marked the point A of B. That means A in brackets B, because point A can be seen, B cannot be seen. That's why I have represented it as A of B at a distance 30 mm in front. At a distance 30 mm in front. That means whenever you tilt, it comes below the reference line. XY at a distance 30 mm below, you can notice the point as A of B. And later on you should not forget to give the dimension. Here A dash B dash represents the true length of the line, which is given as 50 mm according to the question. And this AB is given as this is given as 20 mm above HP. This distance should be of 20 mm, and this is what in front of the lines, in front distance with VP is given, which is given as 30 mm. That means this is the output figure you have to draw. all these things are nothing but this is the rough sketch for understanding purpose. I have drawn this. You should not represent all these things in examination. Just this is the answer. This is what you have to draw in the examination. This is for your imagination. Once you are good at imagination, you can draw any questions like this. Now let us see the second position of the line. Whenever the line is parallel to HP and perpendicular to VP, that means this is what its position is. As I said earlier, we have to imagine with reference to this book. Here this vertical page represents vertical plane, and this horizontal plane page represents the horizontal plane. The line which divides this horizontal and vertical plane is XY line. And here we have taken that the line, if you assume always line in the sense, we have to consider the line as a pen. If you consider a pen as a line, here the first position we have taken is parallel to VP and perpendicular to HP. Whenever the line is parallel to VP and perpendicular to HP, true length of the line can be seen from front view at a distance y/mm above the reference line, and from top view you can see only the top point, whereas bottom point cannot be seen at a distance x/mm from the reference line or from VP. That is what we have drawn. Now if you consider the second condition, parallel to HP, that means it is parallel to HP and perpendicular to VP. Line parallel to HP and perpendicular to VP, like this. Line parallel to HP and perpendicular to VP. Now true shape of the line can be seen from which view? Top view. As always we know that top view can be seen on the horizontal plane, whereas front view can be seen on the vertical plane. From top view you can see the true shape of the line, which is represented as AB or PQ, whatever it is given in the question, at a distance some x/mm in front of VP. That means one of the endpoints on the line will be at a distance of x/mm in front of VP. Whatever the distance x in front of VP will be at a distance in front of XY line or reference line. That means from top view you can see this true shape of the line at a distance y/mm or x/mm in front of this VP. Whereas from front view, that means whatever you are looking is the front view. From front view you can see only this point. The back point cannot be seen. That means this point can be seen at a distance some y/mm above the HP or reference line. That means whenever the line parallel to HP and perpendicular to VP, perpendicular in the sense what? It has to make angle 90 degrees with the given plane. Here perpendicular to VP is given, that means here this line has to make angle 90 degrees with vertical plane and parallel to this horizontal plane. Whenever the line parallel to HP and perpendicular to VP is given, true shape of the line can be seen from top view on horizontal plane. That means here in this case you have to draw the projection of the given line considered from the top view. Always we have to start from the view from where you can see the true shape. Here the true shape can be seen from top view, whereas point can be seen from the front view. If you tilt this horizontal plane, line comes below this XY line at a distance 20 mm in front, 20 mm or y/mm, whatever it is given in the question, and at a height of given x/mm you can see the point on this vertical plane. You can see the point on the vertical plane. The point behind it cannot be seen, therefore it should be represented in brackets. Likewise, the question instead of above and in front, sometimes the question may be asked lying on HP and parallel to VP, like this. or lying on HP perpendicular to VP like this, or lying on VP and perpendicular to HP. That means in-front distance is not given here in this case. Only above distance is given. Or lying on VP with one of the endpoints and parallel to HP. Like this, the question can be asked any way. Only the thing you have to remember is whenever the line parallel to VP and perpendicular to HP, the true shape of the line can be seen from front view, whereas from top view you can see only the point. Whenever the line parallel to HP and perpendicular to VP, true shape of the line can be seen from top view and point can be seen from front view. This is the point which you have to remember. You need not want to remember also. First, if you are able to understand the given question, and everything will be left to your imagination. You have to, as you keep on practicing or as you keep on imagining, you can get the answer. Okay, thank you. Now let us see how to draw the line, projection of the line perpendicular to VP and parallel to HP, and two more cases which we have seen now. Now let us see the second position of the line. Here, with reference to the question, let us see how to do the second condition or second position of the line whenever the line parallel to HP, that is horizontal plane, and perpendicular to VP. Whenever the line parallel to HP and perpendicular to VP. Now let us first look over to the question and read the question once. A line here, according to the question is given like this: a line PQ of length 50 mm is parallel to HP and perpendicular to VP. One of the endpoints on the line is 20 mm in front of VP and the line is 30 mm above HP. Draw the projections. Now, as you read the question, here one thing, the position of line is clearly stated as it is parallel to the horizontal plane and perpendicular to the vertical plane. That means while drawing such type of conditions, as usual, first of all, it is better to draw the rough diagram representing horizontal and vertical plane. As we know that this vertical line represents vertical plane, which is represented as VP, and horizontal line represents horizontal plane, which is represented as HP. And the line which divides, we know that the line which divides this horizontal and vertical plane is a reference line which is represented as XY. Now coming over to the position of the line, here the line's position is given in such a way that parallel to HP. That means here the line is parallel to HP, which is named as P and Q, which is of 50 mm length, and perpendicular to VP. That means this is what the position is. Now, as we know that the true length of the line can be seen from which view? From top view. From top view only you can see the true shape or true length of the line. Actually, we have to start from the view. We know that we have to start from the view from where you can see the true shape. Now here, according to the question, true shape can be seen from which view? Top view. Therefore, I am starting from the top view itself. This is given as always. Projection should be represented with small letters PQ. Means if you put light from the top, you can see the true shape. You can see the true shape. What is the inference distance given here? Here one of the endpoints, that means let us assume P, is at a distance of 20 mm in front of VP. That means this distance is given as 20 mm, and the line, entire line is given as 30 mm above HP. 30 mm above HP. Now if you see from the front view, you can notice only point Q. Only point Q can be seen, whereas point P cannot be seen. That means if you put light from the front view, the shadow of the line falls on the vertical plane. The shadow of the line falls on this vertical plane. That means here you can see only the point Q, whereas P cannot be seen. As this is the front view, we have to represent with dash, Q dash of P dash, because here you can notice only point Q, but P cannot be seen. That's why I am represented it as Q dash of P dash. Now, as we know that here the point Q dash of P dash is at a height of 20 mm above the reference line. That means if the line is above 30 mm above HP, exactly this projection will also be 30 mm above the reference line, which is nothing but XY line. That means this point Q dash of P dash can be seen 30 mm above this reference line XY, and the entire line PQ, the point can be seen at a distance of 20 mm in front of VP. That means from XY line, the point projection P is at a distance of 20 mm from the reference line XY. Now, as we know that always we have to tilt the horizontal plane in clockwise direction up to 90 degrees. Up to 90 degrees. If you tilt the horizontal plane in clockwise direction up to 90 degrees, as usual, vertical plane remains above the reference line XY and horizontal plane comes below the reference line XY. And always we have to start from the view from where you can see the true shape. As you tilt this horizontal plane, this line PQ comes in this position like this. The line PQ comes in this position at a distance of 20 mm in front. At a distance of 20 mm in front, and whereas on the same line Q dash P dash can be seen at a height of 30 mm above this reference line. That means always we have to start from the view from where you can see the true shape. Here the true shape of the line can be seen from top view. That's why we have to start from the top view. That means we know that always top view can be seen on the horizontal plane. I have named it as PQ, which is of length 50 mm according to the question, and it can be seen at a distance of 20 mm in front of VP. That means it is at a distance of 20 mm from the reference line, and this point Q dash P dash can be seen at a height of 30 mm above this reference line. Above this reference line. Q dash of P dash, and you have to give the dimensioning. It is at a distance of 30 mm above. And this line is, one of the endpoints of the line is 20 mm in front. And line's length is given as 50 mm. Line's length is given as 50 mm. You should not represent mm here in engineering drawing, because already above the title block you might have represented that all the dimensions are in mm. That means whatever you are going to dimension on the paper will be in mm only. That's why you need not want to represent once again as mm. Just you have to represent with number. This is the actual output. This is the rough one. This rough figure should not be drawn in the examination. This is for your imagination. Okay, thank you. Let us see the different type of question whenever the line lies or rests on either HP or VP. Now with reference to the question, let us solve the question. That means you can frame any number of questions like this, but only the thing is you should have to imagine. You have to imagine. Here in engineering drawing, your imagination plays vital role. If you are good at imagining if you are good at imagining these things, you can draw easily. You can get the answer easily. Now let us go through the question. A line MN of length 50 mm is parallel to VP and perpendicular to HP. One of the endpoints of the line is lying on HP and the line is 20 mm in front of VP. That means here in the question that it is clearly mentioned that line is parallel to VP. As we know that whenever line is parallel to VP, the true length of the line can be seen from front view, whereas from top view you can see only the point. But here in this question, above HP is not given. It is given that the entire line, one of the endpoints of the line is on HP. One of the endpoints of the line is on HP or lying on HP. Now let us see this condition. Always it is better to draw the rough figure. As we know that vertical line represents vertical plane and horizontal line represents the horizontal plane, and the line which divides the horizontal and vertical plane is nothing but XY line. Now let us come over to the question. Here line's length is given as 50 mm and the line is named as MN. And it is given that the line is parallel to VP and perpendicular to HP. Line is parallel to VP and perpendicular to HP, and one of the endpoints of the line is on HP. That means above is not given here. Lying on HP is given. This is what given in the question. This is what the position of the line, and it is given that the line is 20 mm in front of VP. That means it is at a distance of 20 mm from VP. This is what given in the question. As we know that always as the line is parallel to VP and perpendicular to HP, true length of the line can be seen from front view. This is what the front view is. True length of the line can be seen from the front view, whereas point can be seen from the top view. Now, if you put light from the front view, the shadow of the line falls on VP in between these 2 points. This is M dash and this is N dash. As this is front view, I have represented as M dash and N dash. Whereas if you put light from the top view, you can see only the point M. N cannot be seen on the horizontal plane, which is represented as M of N. Now if you tilt this horizontal plane up to 90 degrees, this point M of N comes at a distance of 20 mm in front. This distance from the XY line will be of 20 mm. This is what the distance is. Now here the projection will be of like this. This is XY line, VP comes above the XY line, HP comes below the XY line, and the line we have to start from the view from where you can see the true shape. Here true shape or true length of the line can be seen from front view in the form of, which is represented in the form of M dash, N dash. Always front view should be represented with letters dash, whereas top view should be represented with the same letters. Here the point N dash is on XY line itself, therefore this is the N dash. From there this is the point M. which is represented as M dash. That means the line M dash is lying on xy line itself in such a way that one of the endpoints is on it. And if you project at a distance of 20 mm on the horizontal from xy line on the horizontal plane, you can see this point M. This distance will be of 20 mm and here line's length is given as 50 mm and the line's length is given as 50 mm. That's what I have represented here. Here the point and the line M dash N dash must be thick. Whatever I represented with the black sketch must be of, the black lines must be of thick and remaining lines must be of thin lines. Here the presentation is also important in the engineering drawing. I hope that everyone is following, and let us see one more type of question. Now let us see one more type of question. A line AB of length 50 mm is parallel to HP and perpendicular to VP. Parallel to HP and perpendicular to VP. Just we have to underline this. And one of the endpoints on the line is 20 mm in front of VP and the line is resting on HP. Draw the projections. That means here in this case parallel to HP and perpendicular to VP is given in such a way that this is VP, vertical line represents VP and horizontal line represents HP. As usual, XY is the reference line which divides VP and HP. Now coming over to the question, the line is parallel to HP and perpendicular to VP and one of the endpoints of the line is 20 mm. As we know that there are two endpoints on the line. Among two endpoints, one of the endpoints is given as 20 mm in front of VP and the entire line is lying or resting on HP is given. That it means above is not given here, resting on HP is given. This is one. It is named as AB. The entire line is resting on HP and here one of the endpoints, if you consider point A is at a distance of 20 mm from VP, in front of VP. Now if you see from the top view, you can see the true length of the line AB, which is represented with small letters AB, whereas from front view you can see only the point B. A cannot be seen. As this is resting on HP, the point B can be seen on the reference line, whereas A cannot be seen. Therefore I have represented it as B dash of A dash. If the line is above HP, you can see this B dash and A dash at a distance, at a given distance above the reference line XY. But here in this case, the entire line is assumed to be resting on HP and perpendicular to VP and perpendicular to VP. Therefore, as it is resting on HP and perpendicular to VP, true shape of the line can be seen from top view, whereas from front view you can see only one point. As it is resting on HP, point B can be seen on reference line and A cannot be seen. As this is a front view, I have represented these points as B dash of A dash. And one common thing is, after representing the position, we have to tilt the horizontal plane in clockwise direction up to 90 degrees. Therefore, at a distance 20 mm in front, that means below the reference line, you have to represent point A and line's length is given as 50 mm. At a distance of 50 mm, you have to draw the line AB. Now that means the projection will be like this: above VP HP and at a distance 20 mm in front, you can notice point A, and the length of the line is given as 50 mm, and as this B dash of A dash lies on reference line, therefore this is what the position is. Now you have to give the dimensioning. This is of 20 mm and entire line length is given as 50 mm. Like this, any question you can solve any type of question related to these categories. Only the thing is you have to imagine sometimes the line will be given resting on VP itself, like that also. Instead of HP, it may rest on VP also. And now you may have got idea how to imagine the given question. According to the question, first of all, you should be able to understand the given question first, and after understanding the question, you have to position the line, you have to draw the rough sketch, or you have to imagine with the book and pen, and after that on the rough paper draw your imagination, and after that you will get the projection. According to that you have to draw the projection. That means this rough work and intent should not be represented in the examination. Just this is what you have to draw is.